All right, let's make a super simple motor. What we've got here is a D battery magnet, neodymium-type. This is just a screw and a little piece of wire. And so what I'm going to do is take the screw and set it on top of the magnet like this. And then I'm going to take the screw and touch it to the bottom of this battery. And what you see is it'll just stay there as the magnet has actually magnetized the screw a little bit. And then what we'll do is touch the top of the wire to the top of the battery like this, and then I'm just going to touch the magnet with the other side of the wire. And what you see when I do that is that this magnet starts to spin pretty fast. Let me come a little closer so you can check it out. I'm going to quit pushing it, but you can tell that it's still spinning. And so again, what I'm going to do is just touch this wire to the side of the magnet like this. Fun little simple motor. Just touching the wire to the top of the battery and then touching the wire to the side of this magnet. See if I can get it, about how fast I can get it going with this. We'll try to get it going nice and high speed. All right. Well, let's take a look at what on earth was happening with that thing. So here is the battery. Here's the wire connecting to the magnet, and then there's the screw. Well, with the battery oriented like this is the positive terminal, so you'll have current running around this circuit. The current will run this way down the wire, and then the magnet has a little metallic skin on it, and so what happens is the current will come in this way, go up, go over into the screw, and then back into the battery, completing the circuit. This is the part that kind of matters the most as far as the spinning. Suppose we have our magnet oriented so the north pole is here and the south pole is here. Magnetic field lines come out of the north pole and wrap around and come back into the south. Right here at this place, we have a current running this way through a magnetic field that points up this way. And what that will do is put a force into the board on this side of the magnet. So what happens is that side of the magnet gets forced in, and so you get a spinning going this way, right? If I were to take this wire and actually just touch it over to the other side, then I would have current running this way through a field that comes up, and this side of the magnet would get forced out at you. So if I touched it over here, this side would come out toward you, it would spin like this. Touching it here, this side of the magnet gets forced into the board, because you have current, field, force into the board. So touching it here or here, it will actually spin the same way. If you reverse the magnet, it would actually spin in the opposite direction. But that's really what's happening, is you're having an electric current run in the presence of a magnetic field, and that generates a magnetic force that causes this thing to spin around.